Assalamualaikum and a very good day class. Now we are in week 13 part 3 video. We still under full range Fourier series, but class for today we'll go to the example 3. So I proceed to the example 3 here. Given the following periodic function, that is now we have ft equal to t squared, which is here the interval for this domain for the t here is between -1 to 1, and then the ft equal to ft plus 2 means that it's t, that is the period of this function is equal to. And then class, we have here two questions. The first question asks us to sketch ft over -6 and 6. And then the second question, you need to find the Fourier series. We start with the first question, that is sketching the graph of ft equal to t squared. In class, we have here ft equal to t squared, where is t in between -1 to 1. So now, when I sketch this graph, understood that this graph is quadratic equation. Okay, means that when t equal to 0, we have point here 0, and then this one 1, -1. When t equal to 1, its function equal to also 1, and then also for this -1, because t power 2 function is equal to 1, so you will have this kind of quadratic equation. And then the period here, which is t equal to 2, and you need to repeat. The next one we have 2 and also 3. Here it will repeat the same pattern, so you will have this kind of quadratic equation. 3, 4, 5, it will repeat. Here we will have this kind of quadratic equation, so all the period are 2. And 6 means that it will have half this. Okay, and then when we repeat for the negative side, same pattern, -2, -3, and then we have -4, -5, and then -6, means that the graph will be like this. Okay, sorry, it is not really correct here, it should be this one, and then like this. Okay, and then for this -6, so going down here up to this one. So this is roughly the graph for the ft equal to t squared. Next class, we need to find its Fourier series. In this case, the first thing understood from the question that the period which is t equal to 2. And then we need to find the angular frequency, which is the angular frequency here used to find an and bn. The angular frequency is given by 2 pi over t. So we have here 2 pi over 2, means that our angular frequency, which is omega, here is given by pi. And then class, we need to find here A naught, because when you want to find the Fourier series, you have to find the coefficient of Fourier series, A naught, an, and also bn. So the first thing here, we need to find A naught. A naught equal to the formula of 2 over t. You need to integrate starting from the lower limit up to the upper limit, our ft dt. So here we have 2 over 2, integration -1 to 1, and our function ft is t squared. So integrate respect to time here, we will have t to the power of 3 divided by 3, and then the limit here -1 to 1. When we solve this one, substitute 1 and -1 in this function, we have 1 to the power of 3 over 3 minus -1 to the power of 3 over 3. So we'll got here class the answer equal to 2 over 3 for our A naught. And then class, we need to find an. An is given by the formula of integration starting from -1 to 1. Our function of ft, you need to multiply by cos and omega t dt. And here, when we substitute function is t squared and our omega is equal to pi, so we will have here an will be equal to integration -1 to 1 t squared cos n pi t dt. And how to solve this equation? you need to use integration by part. That is the formula for integration by part is given by integration of u dv equal to uv minus integration of v du. So class, let's say we let here our u equal to t square, means that our du equal to 2t dt. And then we have here dv, we let dv here equal to cos n pi t dt, means that to find v, it will be equal to you integrate this cos and pi t, you'll got sine n pi t, which is then need to be divided by n pi. And when we substitute here, means that when we integrate t square cos n pi t dt equal to uv, that is t square times sine n pi t, this one divided by n pi, and then minus integration of v du. So integration of this one times du, that is 2 over n pi sine n pi t, and then dt. Okay, sorry, we have here t, is 2t. And then class, again this part, you need to use integration by part. Means that here, let here class, u equal to t, and then we have du equal to dt, and then we let here dv equal to sine n pi t. One, when I want to find this v, I need to integrate this part. Okay, integrate this both. I have here negative cos n pi t divided by n pi. This is for the second part here. So when substitute in this equation, we'll have this one equal to t square over n pi sine n pi t, and then minus 2 over n pi. And in this bracket, we need to use this integration by part. We will have here negative t cos n pi t divided by n pi, and then plus here integrating of cos. Why here plus? Because minus, the formula is minus, and then minus this one n pi t over n pi dt. And then class, when you solve this part, you will got equal to t square over n pi sine n pi t minus 2 over n pi, which is negative t cos n pi t over n pi. I write this one again. I integrate this part. I will put here sine n pi t divided by n pi to the power of 2. And class, remember that we integrate this one starting from negative 1 to 1. So here the limit negative 1 to 1 as well. When we substitute the limit here 1 and negative 1 in this function, we'll got this one as integration of negative 1 to 1 t square cos n pi t dt will be equal to 1 over n pi. Okay, now I substitute all with 1. So sine n pi plus 2 over n square pi squared cos n pi, and then minus 2 over n cube pi cube, and then here sine n pi. And then class, all this we close the bracket, and then now we substitute with negative 1, and then minus here 1 over n pi sine negative n pi minus 2 over n square pi square cos negative n pi, and then here minus 2 over n cube pi cube sine negative n pi. And then class, understood that based on previous lecture or previous slide, sine negative n pi, it is equal to sine n pi equal to 0. And then here cos n pi equal to cos negative n pi. So for this one, this all sine n pi it tend to 0. This one also tend to 0. This one 0 and this one will be 0. And cos n pi equal to cos negative n pi means that for this one I will have 2 over n square pi square cos n pi, and then minus minus means that plus 2 over n square pi square cos n pi, because this cos negative n pi equal to cos n pi. So we have here 4 over n square pi square cos n pi, which is n here equal to 1, 2, 3, and so on. And then class, next we need to form a table to find the pattern of this function. Next class, we need to find Bn. Bn is given by here equal to the integration of negative 1 to 1 t square sine n pi dt. In this case, you can see we have actually t square and also trigonometry functions, so we need to use integration by part. The formula of integration by part is we integrate u dv equal to uv minus integration of v du. So in this case, I need to let u equal to t square, and then when we differentiate this u, we have du equal to 2t dt, and then dv equal to sine n pi t dt. And to get this v, we need to integrate both sides. We will have here v equal to negative cos n pi t over n pi. And then class, for this one, when we integrate this t square sine n pi t dt, by using integration by part, it is u v. So we will have here negative t square cos n pi t over n pi, and then plus here integrate of 2 over n pi t cos n pi t dt. Okay, and then if you see here, we have actually t cos n pi t. Again, we need to use integration by part. We let for this one u equal to t, so du equal to dt, and then here we let dv equal to cos n pi t dt, means that to get the v here, v will be equal to sine n pi t over n pi. And when we substitute here, we use this formula for this integration. We'll have here the integration of t square sine n pi t dt equal to negative t square cos n pi t over n pi. Okay, all this over n pi, and then plus here 2 over n pi. Use integration by part. For this one, we'll have t over n pi cos n pi t, and then minus here integration of sine n pi t over n pi dt. So we need to integrate this one. No need to use integration by part. This is just trigonometry function. When we solve this one class, we'll have here the integration of that one equal to negative t square over n pi cos n pi t, and then plus here 2t over n square pi square sine n pi t, okay, n pi t, and then plus 2 over n to the power of 3 pi to the power of 3 cos n pi t. And here we know that our limit start from negative 1 to 1. When we substitute all this, okay, we substitute the upper and the lower limit in our integration, we will have actually this one, the integration of t square sine n pi t dt. So we'll have here negative 1 over n pi cos n pi, and then plus 2 over n square pi square sine n pi plus 2 over n cube pi cube cos n pi. And then for this one class, substitute with this lower limit so that minus negative 1 over n pi cos negative n pi minus 2 over n square pi square sine negative n pi plus 2 over n to the power of 3 pi to the power of 3 cos negative n pi. And then class understood based on previous, sine n pi is 0, sine negative n pi is 0, and then cos negative n pi equal to cos n pi means that for this one negative all this and plus this one we can cancel out, and also for this one this is positive minus this one we can cancel out, means that we got our bn equal to 0. In summary class, we have a naught equal to 2 over 3. We have solved for an equal to negative 4 over pi square and times 1 over n square for n equal to 1, 3, 5 and so on. And then an equal to 4 over pi square 1 over n square for n equal to 2, 4, 6 and so on. And then we have solved for b and we got equal to 0, means that our Fourier series equal to a naught over 2, so 2 over 3 over 2 plus the sum of n equal to 1 to infinity a n cos n omega, and our omega is pi, so cos n pi t. And we substitute based on this one n equal to 1, 2, 3 and so on. So we'll have here 2 over 6 minus 4 over pi square. When you substitute with this function here, we'll got negative 4 over pi square and then cos pi t for n equal to 1 minus 1 over 4 cos 2 pi t, and then plus 1 over 9 cos 3 pi t for n equal to 3 minus 1 over 16 cos 4 pi t, and then plus 1 over 25 cos 5 pi t plus dot, dot, dot. And for bn, understood it is 0, means that this is the final answer for our Fourier series. So class, it comes to the end of this semester lecture. I wish you all of you best of luck. Success is no accident. It is hard work, perseverance, learning, studying, sacrifice, and most of all, love of what you are doing or learning to do. So class, thank you for all your commitment and attention. I wish all of you best of luck in your final exam, and should you have any problem, please do not hesitate to contact me. Thank you.